Welcome to this set of videos on the thermodynamics of the biosphere. It's based on two lectures that I gave in a short course at the University of Padua earlier this year, and I thought, well, I could make a few videos out of it. What is this about? Well, it's about when you ask why questions. You ask, why does life do the things it does? Why is there life on Earth, and so on? Then sooner or later you get to the physical concept of entropy. And so somehow entropy, Earth, and life are related. And so this is what this short course is about. And I hope you learn things about the meaning of life, if you want. And of course, this is nothing, new. I mean, people have been thinking about thermodynamics of life for a long time. And so in this introduction, I want to just briefly give you a little bit of a flavor of what this is about. So already Ludwig Boltzmann, known for the Boltzmann law and for the introduction of the kinetic gas theory, the physicist, an Austrian physicist from the late 19th century, he already stated that life dwells on the low entropy energy of the sun, so it already mentions entropy. And on the other hand, we have Albert Einstein, who said something about that thermodynamics is one of the most fundamental theories in physics, that in the context of his premises will never be overthrown. And he's actually pointed out that specifically this last part, that will never be overthrown, he aimed at people who are skeptical on principle. Then we have Alfred Lotka, an engineer, an American engineer who studied the thermodynamics of life, and in the 1920s he wrote an influential papers and also an influential book on the physical biology, and where he describes the Earth as a interacting set of engines. On the other hand, he writes about life and maximum power with an evolutionary goal of maximizing power. And so we will hear more about this as well. Then there's Erwin Schrödinger, known by the Schrödinger equation, also an Austrian physicist, who after the Second World War went into biology and wrote a very influential book on what is life. And basically what he gave as an answer is that life feeds on low entropy food, low entropy energy. And we will see that in the coming short videos as well. Then we have Eugene Odum, quite a well-known American ecologist who described ecosystems, and he described actually also in the 1950s an influential paper on maximum power in physical and biological systems, and later on in the late 60s on general strategies of ecosystem development. And then in the 70s, there was Jim Lovelock, who wrote about the Earth being a superorganism. And so he formulated that in the context of the Gaia hypothesis, that the environment on Earth is optimized by and for the biosphere. And his thoughts were also quite a bit motivated by thermodynamics. And so to give you sort of a frame of what you're going to expect in this short course, well, we have entropy, we have Earth, and we have life. And what I want to do in this video is to clarify the connections between these concepts and also to reveal the relevance. And so what you're going to see is, so I split up the talk, or the original two lectures, I split it up into 6 parts. So I'm going to talk first about, the elephant in the room, what is entropy, then why it is so relevant. Then we get into life. What is life? What limits life? That's sort of bringing us more into the context of the Earth system. And then we're going to look at the Earth history, how much did life actually, or what did life do during Earth history from a perspective of thermodynamics. And then in the end, after all, we humans are part of the system. We are also part of life, part of the biosphere. So what do we actually do and how do we affect the Earth system? And so with this, I'm at the end of the introduction, and leave the first video to a separate video.